Okay, today I'm going to talk a little bit about reading methods and results sections of manuscripts. This is kind of the scary place. So how do we look into these and begin to learn and feel more comfortable with these sections? So before I kind of start on diving into those sections, the manuscript should really be a good story. So the idea is that it should begin with kind of a background and significance as to why this is important. Go into the question, especially if it's a research paper. Move from the question into the methods of how they will address the question. Once the methods are laid out, it's basically just doing those methods and producing the results, and then going into the discussion, which is how the data applies to the larger picture. So it should be laid out somewhat like this. They may be labeled differently. So background could be introduction. Question could be hypothesis. There could be a participant section there, which is kind of dividing off part of the methods section. But the idea is still that it should flow from background to question to methods to results to discussion. So before I kind of get into the methods and results, I want to go outside of those sections and talk about finding the question. What is the purpose of the article? So this may be called the purpose, it may be called the hypothesis, it may just literally be called the question. And usually it's going to show up kind of after the background. So after the introduction and right before you get into the methods. It should be clearly stated. And I can't impress on how, if it's not clearly stated, then it kind of makes me question the whole validity of the article. So things to look for, is the question a comparative question? So are they comparing groups? This would be, two groups, maybe one of them gets a drug, one doesn't, or one gets a treatment and one doesn't? Or is it more just looking at change? So the idea that I have a group, say for instance, of nurses that I want to implement this educational program on. So I test the nurses before the educational program, I implement the educational program, and then test them afterwards. So I begin to look at change, which is kind of a group comparison, but it's a group before and after. There are also research questions that relate to relationships. So the idea that this is related to that. So the amount of time spent hand washing is related to the number of infections. So that kind of deal where we're looking at several outcomes and looking at the relationships. Now, relationships can also be expressed as increased risk. So the idea that the less time I spend washing hands increases the risk of infection. And that's the way we generally talk about in health. So as an experienced statistician, the question is the key. So if you come to my office for a consult on a research project, I'm going to want to know what your question is. And we may spend some time refining and understanding exactly what that question is. Because for me, the question drives the methods and the analysis. And when you don't, that's when you get into trouble. So looking at just a couple of examples, here's some original research on hospital experience of older adults with hearing impairment. So their section they've labeled specifically, study rationale and purpose. And they say, the rationale is having a better understanding of perceptions of hospitalization of hearing impaired older adults and addressing communication barriers in the hospital setting would improve the patient's hospital experience and quality of care. So this is their rationale for why they do it. Now they're going to say exactly what this study does. This study was conducted to assess the hospital experience of older adults with hearing impairment and to use the findings to formulate suggestions for improving care. So this one is not a comparison. They're not really comparing any kind of groups. Could be kind of a relationship study, but they're not really talking about the relationship. Really, they're just talking about a different kind, which is just a descriptive study. So it's just to assess the hospital experience of older adults. So that's the kind of question it is. And this one lends itself to more quantitative. They could do it with some kind of survey. They could also do some qualitative research and do some questionnaires, which they actually did. Here's another one. These guys clearly state what the research question that this paper addresses is: how are the domains of nursing practice, nurses' job satisfaction, and quality of nursing care interrelated? So it is a relationship question. So I'm going to expect a certain kind of analysis at that point. But for your thought, it's just kind of differentiating between the three kinds of questions. Are they descriptive? Are they looking at relationships? Or are they looking at differences between groups? There are other kind of questions, but these are the main ones. So now we kind of understand the questions, which we should be setting up the methods and results. Let's go into the methods and results a little bit. So one of the first questions I'm going to ask about the methods is, how many participants are there in the study? So how many are in the study? And then we'll have to make some kind of judgment. Is that a reasonable number? Or how does that number affect how we look at the study? And the reason for this is because of the math behind the statistics, there's always this balance of sample size and effect size. And by effect size, I mean in the clearest form, when we're talking about differences between the two groups, how big is the difference? When we're talking about relationships, how strong is the relationship? So that's what I'm talking about when I'm talking about effect size. So the larger the sample size, the smaller effect size I can detect. So how do I know how big is the sample size? Well, in the article, they may talk about a power analysis they did. That's a special kind of analysis that'll help you estimate how many participants you need for the study. So they may talk about that. They may just use past experience, or they may use previous studies, or you may have no clue what they use. But the idea is if they have a power analysis, I feel more confident that they've actually thought about it before they jumped into the study. If the sample size is small, and by small I mean less than 10, then I begin to wonder about how valid it is in the big picture, or how it represents the big picture. If it's small, say less than 1,000, then or if it's large, say greater than 1,000, then I begin to have other concerns, like how, is what they're finding meaningful. So it's always this balance, but you as the reader need to be aware, because it has some effect on how generalizable this information is. Now, the qualitative research, most of that is done on less than 10, but qualitative researchers will tell you that it's less generalizable. So let's look at this paper, Investing in Human Relationships, looking at practice environment, satisfaction, and care. So they have 136 survey respondents and 21 interviewees. Now this is the one where they actually did two kinds of studies. So they did a basic survey, and then they also did a qualitative study. So 21 is a good size for a quality study. Anything around 10 is decent. They go down to 3. 136 is bigger than 10, so it's a reasonable amount. And for regressions, for the kind of analysis they're going to be doing, looking at relationships, I really do need a sample larger than 100. It would be better if I had 200 or 250, but this is not bad. The next question is, how did they get to the final number of participants? So we'll talk a little bit about that article I just showed you, but also the idea in a randomized controlled trial. They will present you with a figure 1 that gives you a detailed description of how they got there. So it may be that they had 10,000 people signed up for the protocol. They threw out all the females because this research only applies to males. They threw out all of the, the older ones and the younger ones because there was a certain age range they were looking at. And they threw out with anybody with any kind of comorbid or other disorder that could affect it. So they have a nice clean sample, but they may bring that 10,000 down to 2,000 or to 500. But the idea is that you can look at that and make a decision and see how they got to that final group. And is that final group relevant to what you're looking at? So what happens with a lot of the work that you do is like this one. So we're talking about, the practice environment, job satisfaction, quality of care. I've already said 136 is okay for that piece. But notice that they started out with 2,000 people that they emailed the survey to, or they sent the survey out to. They received 157 packets, and I don't remember the reason, but they ended up with 136 complete packets. So that's a response rate of about 8%. That's fairly typical of surveys, because you get around 10% participation. But your question is always, are these 136 representative of the 2,000? And if I was looking at their survey responses, my estimate of the bigger population would be tougher because of that. The other thing, you look at the methods and see, is it ethically done? So if this is a research project, and you can publish on quality improvement projects, but if they said that it's research, and it sounds like a research, there should be some kind of approval from some oversight agency, some kind of ethical committee. That could be an institutional review board, an IRB, but somebody should be approving the research. Without stating that clearly, that gives me some pause for concern. Now, they're going to have their data analysis plan. It should be clear. It should be clear to someone who isn't necessarily a statistician. Now, I can't teach you the design and analysis section, all the different analyses that are used, all this in this short period. But just to let you know, you should become kind of familiar with some of the basic ones. So if you're doing comparing groups, then you should see t-test and ANOVA kinds of designs. If you're looking at relationships, you should see correlations or regression kinds of designs. Now, there are going to be different variations on all of that. But just looking at that kind of general overall, there should be a clear statement of what they're going to do and how they're going to do it. And it should make sense. Now, if you have any questions on a particular analysis, this link will take you to an online stat book that you can look at all different kinds of analyses there are, but you can go and look up the one that they did and see if that makes sense. Now, if we move into the methods section, or the results section. So in the methods section, they kind of told you something about the participants, what they look like, and they told you their plan. In the results section, they should just be stating what the results were of the analysis. Now, this is where the language gets kind of picky. So we have a specific language that we use to communicate result sections. And one of the things we talk about is the p-value or the significance level. And generally, we're looking for a p-value of less than 0.05. Now, that probability value is very specific in that it is the probability of finding what I found with the data, or something more extreme, when the null hypothesis is true. Now, null hypothesis simply means that if I'm looking for group differences, then the null hypothesis would be there's no difference in my groups, so the drug did nothing. If I'm looking for relationships, then there's no relationship between hand cleaning and infection rate. So that's the null hypothesis. So this is just testing the data I've got. Does it look like it came from just a random sample where nothing's going on? It doesn't mean the probability that the null hypothesis is wrong, which is kind of tricky. So the idea that I'm saying that, if I could get this just by random chance, less than 5%, then I'm going to feel fairly comfortable that my drug has an effect. Now, and we talk about it being statistically significant. So then we'd say it's less than 0.05, it's statistically significant. Now, that's different than how we use significant in the language. So, in fact, I used it earlier on, saying this is significant. It normally just means that it's important. Now, when I say statistically significant, It means something very specific. The statistically significant is provided from the analysis, and it just means my p-value is less than 0.05. As I mentioned earlier, this is influenced by the sample size. So I can actually detect something that wasn't important, like a drop in systolic blood pressure of 2 points. If I had a large enough sample, then my intervention could cause this drop, but a drop in 2 points may not be clinically relevant. So the idea that you're always, as you're looking at the article, you're looking to see if they found statistical significance. Then you look at the data, and this is by looking at the means or the R value or the R squared, but look at how big the effect is to see if it's relevant. So it's more than just looking to see if it's statistically significant. So you should have, if you're looking at questions of difference, you should have some measure of the center. That'd be the mean, or the average, the median, or the mode. So something that tells you how these guys scored. So what's their average blood pressure reading of this group and the average blood pressure reading of this group. But as important as having that measure of center, you also need a measure of spread. So they should include something that tells you how much variation there is. Now we're moving toward using 95% confidence intervals instead of reporting like standard deviations or standard errors. All three of those are measures of spread, but the 95% confidence interval gives me a clear picture and says that the mean is right here, and I'm 95% confident that the true mean lies between these two levels. They also, some of the summary statistics may be percentages. So they'll give you a percentage in that population. The variance around that usually is when we're talking about surveys, and we talk about that this is accurate to plus or minus 5%. So that's kind of the measure of spread for percentages. In questions of relationships, it's important to know the direction of the relationship. So you should have some indication of which way this is going. So if I say there's a relationship between hand washing and infection rate, I would like to know that that relationship is negative. That is, the more we wash our hands, the lower the infection rate. You have R's and R squareds, which tell you how strong the relationship is. Now, this is a little tricky. Both of these run from 0 to 1. R squared kind of tells you how much overlap that they have, and you can take an R and square it and have an R squared. But it tells you how much. If it's 1, then that means for every 1 point that one goes up, the other one goes up another point, the same amount. So it becomes a 1-to-1 ratio. 0 is no relationship. So it kind of varies in between there. With behavioral data, we're talking if we get, 5 to 10% overlap, that's important. In some of the more biological stuff, we like to have a whole lot of overlap, like 0.8 or 80% overlap. So it kind of depends on your field, and encourage you as you read these articles to kind of think about what are they saying is an important R and R squared. We talk about relative risk and odds ratios. Those are also measures of the relationship. Now, just kind of throwing in there, they may do some model building. That's kind of the new thing. And there you're just looking for some kind of fit measure. How well does my model fit? So this is from that one paper, and it's their table 1. This is summarizing their analysis. And here they have a very clear kind of laid out in the methods. Step 1, they're looking at the relationship of these 3 items. So I'm going to take these one at a time and look at just job satisfaction, how it relates to the environment, and how it relates to the quality of care. Then we'll do it with all 3 of them in there. So the idea that they can, combine these, and the reasoning is laid out in the article why they do that. They show you t-values. they use asterisk, which is fairly common, to show if it's significant. So this one is significant here, this one's significant here. So you have they don't have R squareds, and I would kind of like to have had R squareds. Or this should be R squared because it's a relationship between these variables. I would have liked to have had that, because I really don't know what the strength of these relationships are other than that they're significant. Okay, and just one more word on tables and figures. The tables and figures should stand alone, so that's one of the places I often go with the results, because that's usually the cleanest kind of picture of what's going on. So looking at the table. Now, in some of the randomized controlled trials, they may have a table 1, which is really nice because it's nice and clear comparing the groups. But if it's not there, it should be in the text on any kind of comparison study. But the idea of looking at table 1 or looking at the comparisons of groups outside of what you're measuring. So, are they equivalent on gender? Are they equivalent on age? And these kind of things, to see if those two groups start out the same before I measure. So again, you're looking for any kind of bias that can creep in. And these tables, all of them that show the means, should show some measure of spread. So I hope this helps. I know it's a little bit long, 20 minutes. I'd love to get to talk to you more about this. Thank you very much.